at least 3 weeks of content that we must cover first. All right, so if you are just joining, skip ahead. I haven't started yet. Frequently output more values for step 8. Okay. So we'll answer this question about the assignment and then we'll come back to the lab. So step 8, which one's step 8? I assume this is the for loop. Okay. So if you are doing the assignment and it's only printing one value out of your for loop, okay, so you should have something that looks like this, and then as we discussed last week, we'd have something like current. Good naming makes it easy for us to communicate with each other, and so I've called it current here, and we basically said something along the lines of current should start at the start. Current should go all the way to the end, and current should increment by a step size. Now, in terms of your for loop only printing once, the first thing that you should check is this, because this is what makes it stop. So first thing, check that. Second thing, check this and make sure this is correct. So if you're only printing one line, you could assume that something is happening here, because a value is being updated and it's causing this to fail. If it comes in once and it works, then it's working the first time, meaning this condition is working the first time. So if we put some values here, okay, and we can have a look at various mistakes. So let's say current starts at 0, goes all the way to 4, and the step size is 80. The first time 0 is less than or equal to 4, so it'll print the line. But when it comes back up again and increments it by 80, 80 is not less than 4, and so you'd only get one line out. So I'd definitely be checking that this condition is correct and also the value here is correct. For example, if let's say step size was not initialized, then you're going to get some random value and it's probably going to be like a really, really big number. So that's definitely something that you should check. The other thing is check this and make sure that the condition is correct. If you've just got the calculation and a print in here and nothing else is affecting current, then these are the only two places that you should have to look. The start, I am assuming, works for you because you probably tested it with the first case. And that is basically all that I can think of in terms of your particular problem. Does that make sense? Does that answer your question? Have I got a really long delay? Okay, awesome. Awesome. Is there any other questions about the assignment? If there is, if you do not have a particular question about the assignment, just say no so we can move along to the lab information. And if you're just joining us, just say hi in the chat. Remember that this is interactive, and it makes it incredibly awkward for me when no one's talking in the chat. So feel free to say whatever you like. You can banter, you can joke, you can talk. Just put stuff in the chat. It makes it heaps easier. Awesome, 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 awesome. All right, let's go back a step. Let's go back to the lab then. All right, so we'll have a look at the lab for next week. We'll start with some maths just to make sure that you understand the maths. Once again, I think I mentioned this last week. We saw some piecewise equations and stuff like that, and it looks fairly scary, but a lot of maths looks scary, but it's really not that scary. So for anyone that hasn't seen integration before, basically the basic premise is, let's say I've got some kind of function. All I'm trying to do is find the area under it. Now, some functions will actually go below this line, and these will subtract, okay, from the area. Okay, so that's the basic idea of integration. Now, for a computer to calculate this, it is fairly difficult. And so what we are going to do instead is we're going to form an approximation. Now, when you first learned calculus, you may have done this. It's called a Riemann sum. And basically what you do is you try and approximate it based on a whole heap of boxes, triangles, or different shapes to try and approximately work out how much area there is in the function. Okay. And obviously, the more of these rectangles we have, the better our approximation. If we get them really, really, really tiny, this would be a very, very good approximation. And if these rectangles are too big, then we get a bad approximation. But at the same time, this is better in terms of speed. Okay, this is very slow. Okay, and so we need to decide for our approximation a good level between these. Okay, does that make sense? Yes, no, maybe? Looking at the chat, I think there's a little bit of a delay. Well, a big delay this time. Yeah, that's quite a big delay. All right. Cool. All right, so we've got a couple of other things. So if our function is continuous, it can go on forever. So we need to choose 2 points such that we measure the area from those 2 points. Okay? And we basically name this one A and this one B. Okay? And then we need to decide how many of those rectangles we want. So this is going to be our N. Okay? But with this N, we don't want, let's say N was 3. We don't want one big rectangle and then 2 small ones. Okay? We want it to be nice and even. Okay? So we're going to have to divide it nice and evenly in this problem. Okay? To calculate this, all we do is we apply a formula called the subinterval length, which is b minus a over n. Okay, so let's put all this information up over here. So we've got n, which is, we've got a and b, we've got n, and we've got h equals b minus a over n. Now it's equals, we're dealing with maths at the moment. All right, now we get into the more tricky part here. So what we want to do, let me draw a more simple function because that's an ugly function. So let me draw a simpler function. Let's say it looks like the one on the assignment, and it'll help you learn it. All right. So here we have our b down here and our a, let's say here. Okay, this follows the similar example on your sheet. Whoops, sorry, very wrong way around. B, A. Should I do that? That's, I think, A and B. I had it right the first time. I confused myself. All right. Now, basically what we want to do is, let's say that our subinterval length is 6, okay? We apply this formula and it will tell us the length, and that will give us the different points. Okay, so we should have 6 points. 1, 2, 3, 4, 5. And the last point is always B. Okay, it's always going to be the very last one. Okay, and then what we do once we calculate at every point, okay, we just turn these into rectangles. Okay, so we grab that and we turn that into a rectangle. Grab that, turn that into a rectangle, 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 grab that, and turn that into a rectangle. And then we can just use basic geometry to add these together. Okay. Now, let's do an example. And we're going to do a little bit of a trick such that we don't have to add each rectangle together. Rather, what we're going to do is, if I've got all these heights and I stack them on top of each other, and then I times them by the width, then that's the same thing as this. Okay? All right. So I can just take the width, which is my h, and I can add just the heights. Let's just look at this part for now. These with minus. Okay. So that's the same thing. All right. And we'll see that in the example. I might copy the example across because my drawing skills are not as good as an actual graph. So I think I already did copy it across, didn't I? I've lost it anyway. It was somewhere. All right, so let me just make that bigger. Screen. I copy the graph across. I think this is what we're doing. I know we're doing different. I changed it. Oh, that's the wrong. All right. Okay, it has the wrong formula on it for some reason. Right, so that's the graph of our function that we're going to work with. Our function is, I need to delete this because this is actually wrong. Our function is negative x squared plus 3x. Okay. So what we're going to do is, firstly, we need to work out our limits. And for this example, we've decided on the limits. A is 1, B is 4. Okay, and you can see the 4 there and the 1 there. They're very hard to see, but it means that we're only calculating the area between these 2 points. We then need to choose the number of subintervals. So we choose 6. Okay, and what you can do yourself when you're doing this task is play with it. Make it 80, make it 6,000, and see if it gets better and better as you go along. Okay, and if you've done integration before, you can test it to the real result and see how good your approximation is when you've got a small n versus a large n. Okay, and if you haven't done integration before, there's plenty of calculators online which will do it, and then you can compare it with yours. All right, so the very first thing we need to calculate is the subinterval length. Now, it's a bit easier to see what that is on this graph here. So we've broken it up into 6 parts. Okay, 1, 2, 3, 4, 5, 6. All right, because our n is 6. From there, we have the length of these. Okay, so each one is exactly the same length, or else our approximation would be very odd. So we need to work out how to calculate this, and that's just going to be h equals 4 minus 1 over 6. Okay, so that gives us a half, which we can see. Sorry, these numbers are really small down the bottom. I'll write them out so you can see, which you can see on the x-axis that 1.5 is here. So you can see that it fits a half nicely. All right. So for example, if we made this 12, we'd see that get even smaller. So it'd be a quarter. Why isn't that erasing? Cool. I might actually move these up a little bit because we'll need some room. All right. So from there, all we need to do is calculate this point here, 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 and this point here. So the very first point is going to be at A plus our H. Okay, so we've got 1 plus a half, and we can see that that's our first point. Okay, we've got 1 plus 0.5. Now, how do we find the value of that? Well, we just put it in our formula. Okay, remembering that f of x equals 1 minus x squared plus 3x. So if we put f of 1.5 in there, we get negative 1.5 squared plus 3 times 1.5, which equals 9 over 4. Okay, and these values are horrible here, but that's what it equals. Okay. For the next one, it's going to be, so this one here, it's going to be a plus 2h. Okay. And if we do that, we get f of 1 plus 0.5 times 2 which is, which is f of 2, which is minus 2 squared plus 3 times 2, which gives us 2. So this one here is sitting at 2. And this one here is sitting at 9/4. Okay, and we can keep going and calculate all of these using this pattern. Okay, so let's do that, but let's not do that so slowly. So we have f of 1.5, f of 2, f of 2.5, f of 3, f of 3.5, and f of 4. And we know this is the end for two reasons. Firstly, we've done 6, and the last one should be f of b. Okay, so it should be this last one, should be 4, because that's the end. Okay, and we get 9/4, 2, 5/4, 0, which you can see clearly is that one, negative 7/4, and negative 4. Okay, is that clear up to that point? If you're happy, put a turtle in the chat or a yes. Awesome, 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 awesome. So we don't have the area yet. All we have is all of these individual heights. Okay. Wrong one. Damn it. We have these individual heights. Now what we can do is stack these heights on top of each other, and the ones that are negative will bring that down. So it'll make it smaller. Okay. So let's stack these together by just adding them together. Plus, plus. Okay. And if we add all of those together, we get -1/4, which if we have a look at the graph, you can see that most of the area is actually under the X line. And so it makes sense that it's going to be a negative, okay? Because there's a lot of area here, okay? But they're close, but there's a small amount more down here, okay? Then all we need to do, yes. And that's why we're doing it this way. And this is usually pre-calc anyway. This is before you do calculus. This is usually the first thing you would do when you're starting integrals. So it's a suitable starting point. The subject does have a math prerequisite of math methods, so it is expected that you have done some calculus, but even if you haven't, this is as far as we go. Okay, it is an engineering science subject, so if you have a look at the subject learning guide, it does say that you need math methods or equivalent, and math methods, if you look up the definition, includes calculus. But even if you haven't done calculus before, that's why we're going through it now. So don't stress if you haven't done calculus. All right. From here, we have all the heights, okay? And we've added and subtracted them, and we get this line, okay? And all we need to do with that line, that -1/4, is multiply it with our h, okay? And that should give our total area. Okay, so times by, what's a h? A half. So our total area is going to be negative an eighth. Okay, so it's going to be something like this. Okay. Sabella's joined us, I noticed. Awesome. All right. So with this knowledge, we're going to construct a program. Okay. And once again, the steps are all given, so you can follow it along, but you should be able to follow the problem as you're going along. If you're just following the steps, then you're not really learning from the problem. And remember, in real life, there is no steps. So you need to do it yourself, and you need to work it out from there. So our problem is going to be, you're given some integral f of x squared plus g of x plus h dx, and you need to approximate it based on what the user enters. Are we all good so far? So just say yes or put a turtle in the chat and it'll all be good. I think there's a little bit of a longer delay this time. All right. Okay, so let's get the next part. Let's get away from the maths and let's get back to the programming part. So we now are going to start this lab, and I want to check something. I think this lab. Yep. Okay, so this is actually really important for this lab. So I mentioned this probably from week 1, and you would have seen every week that there would have been this meaningful name thing. So meaningful name basically means that it should relate to the domain. Okay, so integral approximator, integrals.c, something about integration. Okay, this is being marked this week. Okay, so if you submit lab 1 task 1, you will lose lab 3 task 1 .c, you will lose marks there. Okay, so you can have a look in the rubric that we are marking the file name this week. Okay. In this, we're using standard IO. We aren't actually going to use the math library, but if you want, you're welcome to use the math library in this one. Okay. It's up to you if you want to use it or not. You can do a slight little thing with your squared if you want. All right, now this is where a lot of students make mistakes every year with this question and similar questions. We've got 3 coefficients here, and this is where we have to be careful with our naming. You've got 3 coefficients, so let me just put that back on the screen. So you've got f of x squared plus g of x plus h. Now, what I notice a lot of students do is they will go, now they're going to be floats. They will go float x squared, float x, float constant. Can anyone tell me what's wrong with that? Or have a guess. And if you don't know, just say don't know. Okay? Keep the communication going. So if you don't know something, just say don't know. Or put a, you don't know, put a chicken. All right. So what's the big problem here is that we're talking about the coefficients, okay, of x. They're not actually x. X is a completely different variable, okay? And that's really, really, really important. No, we haven't defined x twice. We've called it x squared and x. This is really important because they're a completely separate variable. Okay. So we need to get rid of these, and we can call this constant is fine, okay, because we know what that is, but it's definitely not x, okay. That doesn't make sense in terms of the math when I say declare 3 coefficients for the x squared, x, and the constant. So we'll call this x2 coefficient. I'll just write it like that. Okay. And then we've got a constant. Yes, they can be declared together, separated by a comma. It really doesn't matter. If you are going to use that, only use it with variables that are similar, such that you don't declare everything on one big line where they're not related to each other. So for example, these 3 could be declared on the same line, but I'd do n on another line, okay? You're not going to get any optimization benefit by declaring it on 6 lines or 1 line. It's not going to make a difference, but it will make a huge difference with documentation. So if you are going to write something like float x squared coefficient, x coefficient with the commas, that's fine, but don't just declare absolutely everything in the world such that it's not clear what variables are where. And really, while you're learning, I would just recommend putting them on separate lines. It makes it so much easier for you, especially if you make a spelling mistake, to go back and find it, and for the reader to find it as well. Okay. There's no added benefit of putting them all on the same line or not putting them on the same line in terms of the code. Then n subintervals. Now, should n be an int or a float? Or don't know? if you are behind, just come up to this point. Isabella, you're not allowed to answer. Unless you get it wrong. For anyone that doesn't know, Isabella is one of the demonstrators in the subject. All right, remember what I said. This is about the communication. Please use the chat. It makes this so much easier. Okay. And I'm trying to encourage you to use it because it is just awkward otherwise. All right. So n has to be an int because it can't be a floating point. You can't have 2.5 intervals. That doesn't make sense. So here, I'm actually going to call this subintervals. I'm not going to call it n, just because it's a lot more clear here what it is, especially with code. With maths, it's a little bit easier because we can bunch stuff up, but with code, it makes it a bit more difficult. All right. From there, we've got our B and A as an int. I'd actually want the coefficients as an int. I might change that actually. Either way, it doesn't really make a difference. And then we get to this do while loop. Okay. An important concept that we did in the assignment, so this shouldn't be too hard. But this time, instead of the steps, it gives you it in a flow diagram. All right, I'll answer your question a bit later because we already did assignment questions earlier. So I'll finish this and then we can talk about that. All right. So we have a flow diagram. Ask the user if they'd like to continue. Does the user choose to continue? And then we have a yes coming back up and a no and ending the program. So this is an important step. And a lot of students in the previous years have kind of just skipped this step and continued. Once again, if this step doesn't work, then there's no point continuing. So here, you'll need to, what's it called? You'll need to implement this using a do while. I don't think anyone really at this stage is having too much trouble with the do while. I might actually change this step around. Sorry about that. I just noticed that that's kind of not quite right. So we might change that. Oh, it actually gives you the code for that. So let's include the code. But I might come back and modify this lab just slightly. If you did it the old way, it doesn't really matter, but the other way would be better. All right, so this is the solution. It gives it to you. Now, there is something really, really, really important here, which is where there's a slight trap. So we've got the choice variable. You would have had something similar on your assignment. You ask the user, would you like to do something? They enter it, and then if they say yes, then they continue. So your while loop or do while loop in your assignment was negative. So if they entered something wrong, then it would continue. Here, if they enter something positive, so they say yes, then it continues. Okay, so you can continue based on the negative or the positive or a value or whatever you like. It doesn't always have to be the same thing. And here, what you'll notice is there is a space here. Okay, and a lot of students miss this space here. In the chat, can you tell me why there's a space there? Well, if you don't know, tell me you don't know. I hope you know, because it was part of the marks for last week's lab, but if you don't know, say you don't know. The chat is very quiet. I'm not liking this. Okay, better question. Last week in the lab, it told you to explain why there was two get cars. We had car, can't remember, something. Get car. Why did we have this get car here? What was the purpose of it? Very, very, very important concept, which it's a really annoying concept, but it is a really important one. We could, but the Scanf does it for us, so we don't need to. And if you use get car here, you're going to need to get cars because we're still getting a character. But why do we have this extra get car? What did you write as your comment to that in the lab? What was your comments? So in the second lab, the lab last week, so lab last week, it said, what did it say? Yeah. Note the getCar function is used twice. Try without to see why. Explained in a comment. Answer explained in video. Beautiful. So someone just said it. It's because of the new line. So whenever we enter something onto the standard in via the keyboard, we press the enter key and we get a new line, and that getCar here gets rid of that new line. So the next thing we get is actually a character. Okay. So that getCar is really important, or else we would have got a new line into our series or parallel last week. Okay. So here, there's a slightly easier way of doing this than having two getCars, and this is using Scanf. So with Scanf, we don't actually need, let's get rid of this. This is annoying me. With Scanf, we don't actually need to worry about the new line, even when getting a character, as long as we put a space before it. Okay, so if we do %C, if we do %C without the space, then you have the chance of getting this new line character. Okay. However, if you always put a space before %c, then it will get any trailing white space on standard in. So that doesn't just include a new line, it also includes spaces and tabs and stuff like that. So for example, if the user entered space, new line, and then the letter H, Scanf would just get the H. Okay, to ignore everything before it. Okay, and as we saw, when you enter a number and you use %d, it leaves the new line on there. And so if you've got either another %c above it or you've got a %d before it, you end up capturing that new line character. So the easier way of solving this problem, and the easier way we could have done it last week with the easier way we could have done it last week instead of having to get cars would have just been to use Scanf and put a space in the front. And I'm on 10 different layers and I don't know which layer I'm on. So let's take last week's example. Example. So last week we had this, okay? And we could have easily rewrote this such that it was scanf quotes space %c and then configuration. A lot easier than having to worry about the two get cars and which order they go in. Okay. So actually the scanf makes it easier to do, but the reason that we did the get car last week is because every single student forgets this space when they first introduced to it. And so get car is a really good way to show this concept. And that's why we did it with get car last week rather than scanf. But now that you know this, you can do this every time. You don't need the space before %d, %f. You only need it when you're getting a character. So be aware of that. Okay, because new line is a character and that's why it gets grabbed. Where if you're looking for %d, well, a new line isn't a number, so it just skips over it and doesn't grab it. Okay. Cool. All right. So make sure you include that space. It's really important. And lots of students are going to fall for that trap. Oh, I'm on the wrong lab. I'm on lab 2 now. All right. Now, the other part of this is that students make mistakes about. So if you've started this lab, just a slight recommendation. Step 3 is kind of in the wrong spot. I didn't notice that when I went back to fix it. Really, you should be doing your declaration inside of the do while loop. But I'll fix that up before tomorrow. If you did do it the other way, either go back, fix it, or don't worry about it. I'll just not worry about it this time because it's my mistake. All right. So at that point, we compile the code and make sure that our do while loop works. Okay, so we just keep entering bad values. No, yes. Oh, sorry. Yes. We're doing the positive. I've got the assignment in my head. We're doing the positive, so we just go around and around in circles every time we press yes. And if we press any other value other than y, then it exits. Now, The next step is another part that's important, and this isn't really about the code at all, but this is about your own I don't know, preparation for exams and stuff like that. What really annoys me about exams and seeing really good students doing them is that most of their marks is just for not reading. And you're just like, but they know that. So make sure you read the documents really carefully. So here it says, add the printf and scanf statements inside of the do while loop. Okay. Every year I see students, they go, oh, looks like printf. I'll just put it after. I'll just keep putting things after. Make sure you read it. This especially applies for the exam where you can't test it. You can't see if it compiles or not. Don't just look at the pictures. Don't just look at the steps. Really read the steps if you want to do well in the exam. Because the unfortunate thing is that even the best of us can miss a step. So just go back and read and reread and reread. All right. So are we all good up to here? I think you're all pretty comfortable with this, but I'd still like to go through it slowly and just point out the points of common failure each year with this question. And we can go through it slowly. We've got time now and we can get through it. All right. So what I might do then, because it has been an hour, is I just want to check this question out. So I'm just going to go to the assignment question that was asked. The first line of my assignment output is not indented. Rest looks fine. The first line is one space away from other lines. So there is no indentation for the output for the assignment. What I am assuming is your problem with the assignment. So make sure you've got these widths, okay? Remember we talked about precision and width in week 2. The other thing is that maybe you've got an extra space somewhere that's after, I know where you might have done it. So if you've got a printf with a new line, just make sure it's only the new line and not a space after the new line. Might be one problem that you have. It's a little bit of a weird question. So just make sure that if you've got a new line beforehand, there's no space there before you print out your table. Other than that, really, because you're in a for loop, it could really only be your width because you can't introduce a space to one, but not the rest. So it's either one of those two things. You've either got an extra space on something above after a new line, or it's the width. All right, let's have a 5-minute break, and then we'll come back and keep going with the lab. The second part of this, the task 2 of the lab, is going to take us a little while. So I might speed up a little bit because I think the second part is a little bit more important because it's a brand new concept. Okay, so let's have a 5-minute break. and then when we come back, we'll get through the first task fairly quickly, and then we'll have a look at the second one so we can go through bit manipulation, bitwise operators in a little bit more detail. Sound good? So 5-minute break. I'll be back shortly. All right, kill the stream. All right, if you're still here, just say so in the chat. It's a little bit quiet this time, which is not as fun. Printf a new line at the beginning. I don't think so, because I'm assuming they're either got extra spaces or they're missing spaces. An extra new line would just mean it's on the next line. So I would assume that it would be a space, or the width isn't implemented. Let's find the lab again. I accidentally closed it. All right, where are we at? Blah, 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 blah. Are we calling functions in this one? No. All right. So now we'll talk about step 8 of the lab. This one's a really good step because it helps you prepare for the exam in 2 ways. So generally on the exam, there's a question that requires you. So this is what's happened in the past. The exam hasn't been decided this year, but it'll probably be similar. One question will ask you to draw a flow diagram, and another question will be to write the code of something based on a problem statement. So knowing how to draw this yourself from the problem is very, very handy. Everyone's solution is going to be slightly different, but it should still work. So this is something that you should definitely consider having a play around with practicing. So here we've got the flow diagram. You can see this in green. In the chat, what's the green part? If you remember from last week, and if you've done the assignment, the green part that kind of structure there should look somewhat familiar, even if you can't read the text inside. Just with the arrows and the way they're pointing. The chat's really dead. And once again, if you don't know, just say don't know. Refresh this. Nothing there. quite. No, so it's definitely not a do-while loop. We just saw that before. The do-while loop looks something like this. Move it across. Okay. Do-while looks something like this, where if we have a look at this, sure, you can answer if you like. If you don't get it right, I'd be very surprised. All right, so it's definitely a for loop, okay? Remember, our for loop has 3 parts, okay? And that's why there's 3 boxes that are green. Okay. Let me just move this layer up top. So it definitely has to be a for loop because a while loop doesn't have 3 parts. It just has 1 condition. And so this part here is the initialization. This part here is the condition. And this part here is the update. Okay, so you got the initialization, the condition, and the update. Okay, and you would have done this in your assignment. Okay. But this time we actually are using I because we are iterating over something. And we'll see that with the function, with the details that I give you. And you can see here that I starts at 1. So if we declared I just beforehand, okay, and generally try and declare these variables just before the for loop, we could say I is 1. Is I less than subintervals plus 1? I less than subintervals plus 1, and increment I plus plus. So from that diagram, you should be able to quickly put together a for loop. If this was in the exam, you should be able to grab that and quickly put that together because it gives you the answer. Okay, it tells you exactly what it's looking for, and you just need to know that the very first one, okay, the pink one is your initialization. Let's go yellow. The yellow is your condition. It's not a very good yellow. And the last one there is your update. Okay, so get used to that diagram. The diagrams are on the resources page as well. So you can have a look at an example of a for loop. And you can see the same thing. You've got the box here, you've got the question here, and you've got the increment here, or the update here. Okay, so they're on LMS, so you can find them in the resources part. Get used to seeing that. You're going to start seeing that a lot. All right, and the reason we are introducing these flow diagrams, even though I give you the steps and tell you how to do it, the reason we're giving you the flow diagram is so to prepare you for the exam. Okay, so it's not just there to look pretty. All right, so we'll come back to the for loop, but I'm on 10 different layers. This is really annoying. I don't even know what layer I'm on. Let's get rid of all of these. Cool. That's clean enough. All right. So now we're going to get to step 9. Step 7, sorry. Well, step 7 we've already done. That's ask the user to store the user's input. That was those printf and scanf statements that we did earlier. Okay, so if we go back a little bit somewhere, why is this not working? I've been playing up tonight. Okay, so step 7 is that. Okay, we've already done that. Okay, so that was step 7. That was 1, 2, 3, 4, 5, 6 printfs and 6 scanfs. Okay, so step 7 is already done. Then we calculate the subinterval length. And how would we do that? How would we calculate the subinterval length? We'd go back and have a look at the formula, which was h equals b minus a over n. We need to translate this to c. We haven't declared h yet, okay, which is really important. If you haven't watched already the video on scope, I redid it yesterday, and it's up on YouTube. I also talked about scope for a very long time in the last video, but we don't want to declare everything at the top, okay? We're doing some fairly simple problems at the moment, but we're going to get a lot more variables soon. And so declare them when they're needed, when they're used. And that's also why I want to go back and change that first couple of steps. So declare a float. Okay, so this is step 9. And we're going to declare it here. We're not going to declare it earlier. H becomes b minus a over n. Yeah, I'm just going to put the brackets there because it's not multiplication. So don't forget that there is implied brackets in mathematics. That's something that a lot of students forgot and lost marks for in their very first lab, and some in the second lab with these brackets. Okay, you do need brackets. All right. Now, you might need to typecast. I think I declared B and A. No, B and A. They really should be floats, but they're ints here. I think if you used ints, then you'll definitely need to typecast. Okay. There's no way around it. Okay, so let's add the typecast anyway, and then we can decide which type we want later. I think I might change that around because I think for you guys, you should be able to deal with B and A being floats, and you should be able to deal with the coefficients being floats. Makes it a little bit harder, but you're smart, so you can do it. All right, step 10. Now, this is a step that's important, and this is where a lot of students that are obsessed with declaring everything up the top make the whole program not work properly. Okay, because in this step, we initialize the area to 0. Okay, so we got float, area becomes 0. Now, some students went about this previous years, grabbed that, put it right up the top of their code. The problem with doing that is that when you come back again, okay, the area is going to be using the area from the previous calculation again, rather than resetting it to 0. And so the first calculation comes out perfect. The second calculation comes out wrong. Third, fourth, fifth, and every single one that follows will come out wrong, except for the first. So please, 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 I don't know what the obsession is with declaring everything up the top. Just don't, okay? Declare it where it's needed, okay? It actually makes your life heaps easier. And I talk about that in the scope video. You're just making your lives harder by putting everything at the top. It might seem like it's easier because they're all together, but just putting things together doesn't make things easier. There's no logic in that. Okay, so if you are one of those people that want to put it up the top, you're going to find problems when you get to this stage. All right. Add the for loop. Now, I've actually given you the for loop. This is another place that I've given you quite a bit of code in this one. Yeah, you can write the float on either side. It doesn't matter. I just put it there so I didn't have to move as much text. It doesn't matter if you put the float at the front or the back, as long as the denominator or the numerator are cast to a float. It doesn't make a difference. It really doesn't make a difference. Because as long as one of them's a float, you have to use a floating point division. There's two pieces of hardware. There's floating point LU and an integer LU, and you cannot put an integer and a float into a floating point division. It won't work. So the computer needs to turn the other one into a float to make it work. So if you want to put the float at the front, the back, that's fine. Just don't go crazy and put it everywhere. It's just unnecessary. Okay. As long as it's either the numerator or the denominator, it's fine. Yeah, that's it. All right. So then we get to our for loop, okay, which we saw earlier. Okay. It's a little bit neater than what I drew up before, but you can see this I is 1. You can see, let's pick another color, green. I is less than subintervals plus 1, which is here. And then we've got increment I, which is here. Okay. Now, it says in there a little comment, summation calculated here. Now, the reason that I broke this up into 2 steps is so that you can clearly go back and think about your problem and make sure, now it's on one of those layers. I've got lots and lots of stuff here. But remember, we want to add up all of these lines, okay, such that we get the height of the whole thing. And then we times it by the width, and we get the area, okay? So the summation is talking about that, adding up all the heights, okay? Now, I give you the calculations for this, but there's really no reason why you shouldn't be able to do this yourself. So if you want to challenge, just hide that part and do it yourself. But we can have a look at it. It's not a very complex calculation. Why isn't it pasting? All right. So then we fill it in, okay, and we get something that looks like this. I'm really not winning with the layers this time. Okay, so we fill it in and we get something like this. Now, all we're doing here is, let's ignore the area part for now, but we've got the x squared coefficient. Okay, we've got the x squared coefficient, and we're timesing it by lower limit plus I times subinterval length times lower limit plus I times subinterval length. So this is just x squared, okay? And if we remember back to our example, our lower limit was 1. We added that with 1 times 0.5 the first time, remember our, and then the second time we did 1 plus 2 times 0.5, okay? This is the same thing here. This here is x, okay? And this is why we didn't call it x, because this right here is x, okay? Remember, this is x, okay? Every time we go around the loop, we're changing x, okay? So we can see x here as well, and we can see x here as well, okay? X times x gives x squared, okay? And then we've got the x squared coefficient, which for us is, I think it's g or something. So we've got the formula fx squared plus gx plus h. So this part here is our f, this part here is our g, and this part here is our h. Okay? And all we're doing every time we go around this loop is just changing this 1 to a 2 to a 3 to a 4 to a 5 and to a 6. Remember, our subintervals in our example went all the way to 6. Okay? Which gave us 4, which was the end. Okay? So this loop is just going around and around and around and doing those calculations we saw right at the start. The other thing it's doing is it's adding up. Now it says area here, and we're using this as an intermediate variable. You could, if you want to be a little bit more technical, maybe call that height and then multiply it by the area, if it helps you. So here we're just adding that height up, when it goes negative, it's just going back down, such that it gives us the height of the total area. Okay. Then we remember back that we had that subinterval length. Remember, every interval was that length. And by timesing it by the width, we get a box. Okay, and that's our area. Okay. So this here, this whole thing calculates our area. All right. Does that make sense? Okay, so we're adding up the height of our area, and then we multiply it by our width. It's a rectangle, so that gives us area. So if that makes sense, just say yes, or if you don't care, just say don't care, or whatever you want to say. Or just put turtles in the chat. Or lizards. It's very quiet chat. Awesome. And we're done. The last thing that is there, so let's move this out of the way. So multiply the area by the subinterval length. That's that there. And then print the area to the screen. So just print out area. Okay, I think you know how to do that. Printf %, F, and you're done. Okay, remember that this asks user to continue. We've already done that earlier. So that's the first part of the lab. Now I give you a bit of code. So you need to be good at documenting. And the other thing is, we are marking your variable names for this one, especially because of that X thing. Nothing should be called X. It should be X coefficient, X squared coefficient. Don't call it N, call it subinterval length or something like that. Don't call it A and B, just call it lower limit, upper limit. And you'll get full marks for it if you give all the right names. And obviously the math works out. The other thing is, and as I mentioned, a common mistake in previous years was students declaring everything at the top. And so it works the first time, but it doesn't work the second time. So make sure you do the user chooses to continue at least once and try another example. Because if you don't do that, then you're only testing it once, which usually is the easier case. Okay. And because basically what we're saying there is when you go through it once, it works. But when you go back up, if you haven't reset everything, you're going to use values from the previous calculation into your new equation, and they're going to cause problems for you. Okay. Cool. All right. So now we're going to do some bitwise. I might have a quick see responded. All right. Checks. Oh, really? All right. I'm just going to respond to an email and check something. I'll be back in a couple of minutes. And I'll just say 5 minutes. Sorry. And then when we get back, we'll do bitwise and bit manipulation, which is really cool. All right. All right. So now we're going to do some really cool stuff. I'm going to start a new file because this file's just going to crap. Cool. Start on the left. Beautiful. All right. If you're still here, just say so in the chat. I'm going to put up an example. So int a becomes the result of 4 and 5. Tell me in the chat what value would be printed. And then I'm going to add a slightly harder one. Int b becomes 4 bitwise and 5. And what gets printed in this second one. And then we'll discuss, and then we'll find out the answer, and then you'll be amazed. All right, so what would be printed? What would be printed for the first one? And then what would be printed for the second one? Maybe I'll change this a little bit. Let's put let's make this A % D /n. And then we've got A. So that's a nice easy one. And then we've got a harder one down here, which I don't expect you to know, or you might know. But it's there anyway, because I want to talk about it. All right. So what's the first one? We've done this week. We talked about it. $46. Interesting. You don't know, just say you don't know. Maybe they've gone for a break as well. I might just give it another minute. First, I only got one answer in the chat. All right, so let's have a look at this. So we remember that our definition of true and false, true is not 0. Okay, so here we've got a true and a true. Okay, and we've got a relational and or a conditional and. So we remember that a true for a relational should give us a 1. Okay, so because it gives us a 1, we should just get A is 1. Okay, so remember from the lab, we did the presentation on the if statement and the fact that it returns a 1. If I have if 4 plus 4, I'll get a 1. I'll get a true. With a relational operator, if I do just a value, it's automatically true unless it's 0. Okay, so we get a 1 there. In terms of submitting the assignment, I put up an announcement about that with the instructions. Does that make sense why A is 1? I don't know if I can share links in the chat. Let's have a look. Let's try. Copy link. Paste. The link's there if it works. I think it should work. Yeah, it does. All right. The second one we'll come back to later, okay? Because this one's actually a little bit more complex, okay? So the thing to notice, the difference between them is we've got this here and this here. So this here is our conditional and or a relational and, where this here is a binary and. Okay. And now let's go have a look at what that's all about. So let's take two. Let's not do ints. Let's do cars because they're nice and short. So I'm going to do car x, car y, and I'm going to give them values. 1 0 1 0 1 1 1 1, and I'll do 0b 1 0 1 0 0 0 0 0. That should be a good example. All right, so we are now going to have a look at what these values come out as using 3 different binary operators, and then we can have a look at shifts as well. So we're going to look at a binary OR, a binary AND, a binary XOR. Yeah, we'll have a look at the other ones in a bit because these are all binary, so that makes it easier. All right, so let's have a look at the first one. So I'm going to declare car Z, and I'm going to give it the value X binary OR Y. Now, the best way to solve these problems using binary, if you get something in the exam or you just want to solve it yourself, is to get the 2 values, so the left and the right-hand side of the operator, and stack them on top of each other. So X is 1 0 1 0 1 1 1 1, and then the Y is 1 0 1 0 0 0 0 0. And then all we do with our OR is so in terms of digitally sign, it means click I agree, and it's not just the AIM module, it's everything that's listed there. Okay, if you agree to that and you don't actually follow it, then that will be used as evidence. Okay, so yes, digitally sign says I agree. So take it seriously. If you cannot satisfy what's there, then don't sign it and don't submit the assignment. Okay. So I'll put this on the screen just quickly. Sorry for those that are listening, but this is really important. So it's not just the AIM module. It needs to be your independent work. You're not presenting it as your own. It hasn't been purchased or commissioned. You haven't made it carelessly available for anyone else, and that you're aware that penalties for academic integrity are serious, including failure the assignment, subject, suspension, expulsion, appearing on transcript, and can affect visa status. So if you're aware of all of that and you haven't copied anyone else's work, you've only used the resources from me and the subject and your demonstrators, then that's fine. Okay, and then you can click agree. If you cannot agree to that, don't submit the assignment. As simple as that. Okay. All right, so what we do is basically we do the OR like we would with our normal OR that we did before, our conditional OR, but we do it between each bit. So 1 or 0 is a 1. 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 0 and 0 is a 0. 1 or 1 is a 1. 0 or 0 is a 0. And 1 or 1 is a 1. Okay, and that would be the answer. Okay, I'm not going to convert it to decimal, but that's what would be stored in Z. Okay. All good, all good. Good luck with your assignment. Next time, come at the start of the video. Then we've got and, which works pretty much the same as before. Okay, so that here, we do the same thing. We stack them on top of each other. 1 and 0 gives 0, 1 and 0 gives 0, 1 and 0, 0, 0, 0, 1, 0, 1. Okay. We then also have another operator that we don't have a relational one for, which is called an XOR, which is exclusive OR. So basically that means both bits need to be different to get a 1. So 1 XOR 0 is a 1, 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 0, 0, 0, 0, because they're the same. Okay. The next couple of operators we'll look at is some other operators. So we've got a binary not. We've got a shift right and a shift left. Shift left. Here, our binary not is very simple. So if I do not x, it just flips all the bits. So 0, 1, 0, 1, 0, 0, 0, 0. Okay. And that's all the not does. Now you have to be really careful about this operator, because if this was an int, let's say, then it also flips, even if I only specify 8 bits here, it flips all the other bits at the front to 1s as well. So be really careful when using a not. Shift right, so let's say I do x, shifted right 3 places. So I've got 1, 0, 1, 0, 1, 1, 1, 1. All this will do is move everything across 3 places, whatever the value is here. Okay, so moving it across once, we get 0, 1, 1, 1. Now what you'll notice is that we introduce a 0 at the end. Okay, so whenever shifting right, we get zeros. Whatever pops off the end, we lose. Okay, so if we shifted 3 times, so this is once, this is, I've completely lost where I'm at. That's twice, and then 3 times, we'd get this. Okay. Why are we so far behind? Same with shift left. Okay. Let's just do shift left 1. So if we're shifting left, we go the other way. Okay. So we'd go this way instead. Okay. Whatever comes off, we lose. Okay. And we'd get that. Whatever's coming in is always a 0. All right. Does that make sense? All right. I was going to cover bit manipulation and the second part of the lab, but I think everyone's kind of focusing on their exams. Not exams, assignments. So unless you're really interested, well, if you are really interested, let me know now in the chat, because I might have to leave it here otherwise. If we have 3 or 4 people that are interested, I'm happy to keep going. But it's a little quiet. It's a little awkward. You're interested, but you haven't been. Okay, if you're interested, this is the important thing. I need your communication, okay? Try and use the chat constantly because it makes it really awkward for me otherwise, okay? So just say yes, no, don't know. It doesn't have to be anything great. It's just I need some communication because I feel like I'm talking to myself otherwise and I'll go mad. All right, so there are some people here. You're just not using the chat. All right, you need to use the chat, okay? Just try and use the chat because it's a very small group, and so it does. I don't know if I'm talking to no one or if I'm talking to myself. All right, so all of that's pretty useful, but there's some common operations that we constantly use when we're doing bitwise stuff. And for anyone that's planning on doing, so this is more for the undergrads who are going to do electronics, they're going to use this quite a lot because you need this for embedded quite heavily. This is still helpful for other people that want to do bit bashing and things like that, but this especially applies to first years who are going to use this quite a lot if they're going to do electronic engineering. So here I've got 4 common operations. Oh, we didn't answer our question. Maybe we should answer our question. So I'll go back to our question of what actually gets printed. So what gets printed for the second one is going to be 4, and I'll explain why. So we've got 4, which in binary is 100, and we've got 5, which is 101. We add them together, we get 001, which is 4. So B will be 4. Okay, so that's the last one, and that's what gets printed. Anyways, let's come back here. All right, so now let's have a look at this. So we've got 4 common operations. I'm not too worried if you don't understand them at the bitwise level right now, but the important thing is that you can do all 4 of them. So let's take a small variable, let's call it A, and let's set it to 11110000. Now, in terms of bits and their numbers, this is bit 0. This is bit 1, 2, 3, 4, 5, 6, and 7. Okay, so we start from the least significant bit or the smallest bit at the bottom, and we move our way up. Okay, so be careful about that. We do start at 0, as you'll see with arrays soon. We also start our indexes at 0, but they're going the other way. Okay, so sorry for C being confusing, but just the way it is. All right. So from here, we've got a couple of different operations. The first one is setting a bit. So if I wanted to turn this 2 into a 1, all I need to write is this. Okay, and that changes bit 2 into a 1. If it's already a 1, then it'll just be a 1 again. Okay. Clearing a bit changes the bit to a 0. So we've got that, we've got that, we've got this. So let's say I want to change bit 6 to a 0. That changes bit 6 into a 0. Okay. So if we have a look at that, after this first line, we should have 1111, 0100. And then after that line, if we change bit 6 to a 0, we should have 1, 0, 1, 1, 0, 1, 0, 0. Now, keep in mind, if you set something to 0 that's already 0, it just stays 0. If you change something from 1 that's already a 1, it just stays a 1. Okay? Because we are going to use that to our advantage as well. The last one that changes bits is a toggle. Okay, and all this means is that if it's a 1, it changes it to a 0, and if it's a 0, it changes it to a 1. So let's pick a bit here. Let's pick bit 7. Okay, so here it toggles bit 7. Okay, so because bit 7 is a 0, it changes it to a 1. Because bit 7 is a 1, it changes it to a 0. And I don't know what I'm doing. There we go. Cool. Does that make sense? Say yes, or put a emoticon in the chat if it makes sense. If it doesn't make sense, just say no, and we can clarify. You don't have to worry about all of these operators and why they're in this pattern. Leave that for a task for another day. But just understand what setting, clearing, and toggling does. And if that makes sense, then we'll continue with testing, because testing is slightly different. What's the delay? It's about 10-second delay. It gets overridden. Sorry. It gets overridden. So it doesn't stay the same. As you can see, there's a compound operator for each one of these. So we are doing assignment. So we are changing the value of A. What happened to all these interested people? Let's continue. So from there, hey, we got a crocodile. I like it. From there, we've also got testing a bit. And this is one that a lot of students do wrong when it comes to this lab. Because firstly, it has to be used as a condition. Okay. And it's only testing if the bit is 1. Okay. We'll talk about how to deal with it being 0 in a second. So if I wanted to test if, let's say bit, let's say if I wanted to test if bit 4 is a 1, then I would write A and bitwise and 1 shifted to 4. So that basically says, so just do a printf, bit 4 is a 1. Okay, with the new line. Now, for testing 0, a lot of students go and change this 1 to a 0. That won't work, okay? It will actually do nothing useful, all right? This is always a 1 here, okay? The 1 doesn't change. If you want to test if it's 0, all you need to do is put the whole thing in brackets and put a not at the start. Okay, and that's a relational not a binary not. And now I've lost how many brackets I've got. Okay, so basically we're saying if this is false, we just make it true to check for a 0. So that would say that if that was true, printf bit 4 is a 0. Okay, so that's how you check if it's 0. You just not the whole thing. Okay, don't ever change that 1. Okay, I know it's tempting, but that's actually part of the bit manipulation. They all need to stay as 1. Okay, and that's important for bit manipulation. All right. Does that all make sense? Because now we're going to get to the confusing part, which is more my fault, but I like the example, so you have to deal with it. Are we all up to this point? I need to take a quick break in a second. Actually, let's do a quick break because I think everyone's a little bit off time as well. The chat's kind of weird. So let's take a 5-minute break. And when we get back, we'll talk about the problem because the second task isn't too difficult. It's just that the problem is a little bit complex. And you can blame me for that. So let's just have a 5-minute break and then we'll talk about the problem. Because it's a really good problem, but it's a little bit hard to understand when you first read it. All right, so I'm just gonna have a quick break. Fill up my drink. Can I explain that once again? Certainly. All right. I assume you mean the testing part. All right. So let's do the testing part. So I won't worry about what comes out of this test because it's actually not 1. It's actually another value, but we know that anything that's not 0 is a true. So basically here we have this testing a bit, which is a and 1 shifted. So let's pick 4 again. Okay. Now, if there is a 1 in bit 4, then this evaluates to true. Okay. It's a value that's not 0. Okay. Okay. So this evaluates to true when bit 4 is a 1. And if I want to try bit 3, bit 2, bit 6, whatever, I just change that value here. If I want to do it with a different variable, then I just change the variable. Now, our not operator, if I have an if statement and I do, let's say, 4 is less than 5. Okay, we all know that that would come out as a 1 or true. To negate that, I can put this in brackets and just put a not in front of it, and that would make it false. Okay, so knowing that A and 1 shifted to a bit, I'm sorry, I should actually specify the bit, let's say bit 5, knowing that that comes out true when the bit is a 1 and a false when the bit is a 0, we can just put a not in front of it for finding zeros. So then it gives a 0 when there is a 1 and a 1 when there's a 0. Make sense? What's going on with this? Why is that being silly? Cool. Who's still here? All right, if you're still here, say hi or put an emoticon in the chat, and we'll talk about this problem because it's a little bit of an interesting problem. And I'm actually going to use the example that's given because I think I can explain it a little better without it. All right. Red chicken. Beautiful. Here's a chicken. It might be a rooster. Not 100% sure. Is it a chicken or a rooster? Why is that on a different layer? Ah, okay. Why have I cut? Move. There we go. All right. So you've all heard of a lock before, something like a padlock or a door lock or something like that. And you might have seen a lock with, I don't know, like a dial on it, like on a safe, or a bike lock with some pin presses, or on a door lock, a security lock. It might have like a whole heap of numbers and you have to put them in. Okay. So you understand the concept of a lock. Now, we have lots of different types of locks. Okay. And what's important with a lock is usually the combination. Okay. And sometimes also the order. Okay. So for example, if I tell you the password is 3262, then you know the combination is that. Okay. I'm actually going to take that away. I need a better example. Okay, so if I tell you the combination for the lock is 3268, and there's a keypad on the wall to get in, you just press 3, 2, 6, and 8. Then you're allowed in. Right? Yes, this one isn't a math problem. So, yay, we get to do some non-math. So, I think this is probably, well, I think next week is all math. We're going to do some audio. We're going to do some really cool stuff. But because of the engineering side of things and science kind of things, most of it's just applied maths. So, and the other thing is that I love math. So, what can I say? But I've put some really cool labs, but we need a lot more of the basics before we can do those. So there'll be things like audio and stuff that won't involve math. But we need some real basics first. Not basics, we need pointers and stuff like that first before we can do that. All right, so lost my, there it is, beautiful. All right, so this here would be some kind of lock combination. And what's important here is both the combination and the order. But let's say we don't care about the order. Okay, we just care about the combination. So you could enter 2683 and it'd work. You could enter 6283 and it'd work. So as long as you put the combination in correctly, it'd work. Now, this means that we won't have doubles of any value. And you cannot get one of these values wrong. So for example, 26183 would be wrong. Okay. And so would 226182, that would be wrong. Okay. So we're concerned with the combination, but it needs to be together as one full combination. Okay, you can't insert other values inside of that combination, nor repeat itself inside of that combination. Does that make sense? This is actually kind of funny that the one that the students get most confused about is the non-math one. Let's make sure everyone understood that. If you understood it, just say yes or koala. Just check something. Forums. That's why it doesn't tell me. All right, cool. All right, so if you were in charge of this lock, the first thing that you need to do is set that combination. Okay, so set the combination. And then the second part is going to be unlocking the lock. Okay. So the first part of this problem is setting this lock. And the way that you do this is you choose which of these positions. So I'm going to call this 0, 1, 2, 3, 4, 5, 6, 7. And I'm going to toggle these such that they become on or off. Okay. So I'm going to choose my combination as 7, 1, and 4. Okay. So it means that anyone that wants to unlock it, they just need to know these three values in any order. It doesn't matter the order. Okay, so they can enter 7, 4, and 1. They can enter 1, 4, and 7. They can enter 1, 7, 4, and so on. Okay, so they can enter any combination. Then we get to the unlocking of the lock. Now, what's important here is that what we actually do to unlock the lock is we make a copy of this, okay, and lock it away. Okay, so we've got the code. Okay, I'll just put this up here. And this is going to be our lock copy. So because what we're going to do is we're going to transfer this and make a copy of it. And we're also going to use this to unlock. Okay. And all you need to do now is basically all we need to do is check are all of, let's call these, let's call them pins off, okay, for this example. Are all the pins off, meaning the blues are gone, okay? If all of those pins are off, then the lock is unlocked, okay? And we can open it and we can get the ice cream that's in the fridge. All right. So basically, let's say the person comes along and they try and unlock this lock. So they do 1, 4, 7. The 1 should unlock that pin, unlock that pin, unlock that pin, and it's open. Okay, the lock is open and they can get the gold. Okay, or whatever's hiding behind that lock. Okay, so all we're checking for is, are all the pins off? Okay. Now, let's do this example again and have a look what happens when they enter something wrong. So this time they enter 1, 8. So here, this first pin is gone, but then they enter an 8. So we should reset the lock. Now, we made a copy of our original lock. So all I do is I just transfer that back to the lock such that it becomes this again. And then they can retry again. So they do 1, 4, 2. So they hit that one, they hit that one, and they hit the 2. So we go back, reset the lock again. Okay. Now we know when it's wrong because it'll be off already. So if it's off already, then we don't. Then we reset it. If it's a 1, then we just make it a 0. Okay. And when they're all off, the lock is unlocked. Does that make sense? And then we'll have a look. Well, we use our testing. Wherever it went. So we can test a bit. Where is it? We can test a bit to see if it's a 1 or a 0. Yes, we're checking them individually because the user's entering each one individually. Okay. All right. Now that's, we've been using the word pins, we've been using the word off, we've been using these values. Let's have a look at the binary version of this now. Now, this version is inverted, meaning that my example was that they all have to be off when the lock's actually unlocked when they're all 1s this time. All right. So the lock password will be an unsigned 16-bit variable, which is an unsigned short, initialized to all ones. Okay, so all ones, they're all unlocked. It's unlocked at this stage. Okay, this is the unlock stage. Then set to what the user decides, and the lock will be considered unlocked when it's equal to all ones. Okay, so when the user gets everything back to 1, the lock's unlocked. The first stage of the program is to set the lock password. This will be done by requesting values from the user and toggling the corresponding bits until the user chooses to end by typing -1. So this is stage 1. This is the user setting the combination. So we create our lock password variable. I've got lock written down there so you can differentiate it from the copy later on. The user enters 5, so we set that bit to a 0. Okay. The user enters a 12, so we set that bit to 0. So the combination at the moment has a 5 and a 12. Now, if the user enters the same thing twice, then it just sets it back and gets rid of it. Okay, so if we go back to our example with this, if they entered a 7 when they're at the setting stage and they already hit a 7, then it just get rid of it. And then the password would be 1 and 4 again. Okay. Stop scrolling, stop scrolling. So our password at the moment is just enter 12 and you get in, which is not very secure, but then they enter a 6 to toggle the 6. And that's our password. So if they enter a 12 and then a 6, then they get in. Or if they enter a 6 and then a 12, they get in. So either of them, in either order, they get in. It's not very secure, but for the example, we've kept it nice and small. Okay. So you can see on the lock that those 2 bits are 0. Okay. So let me copy this across. And we'll finish up this example and we'll probably leave it there. So the lock password is now 111110, 111110, and then ones. To unlock, the user needs to know this combination. So the user only needs to know where the zeros are. They don't need to know where the ones are. The second stage of the problem is to get the user to unlock this lock. This is first done by creating a copy of the lock password and storing it. We do not want to lose the original password. Okay. So we're running out of room. We got more room down here. Not really. Let me do one thing. Canvas size. Blah. Let's go 4,000. Make more room. All right. So is this a picture? Yes, it is. All right. So example continued. This is now stage 2. So at stage well, the step E2 is just checking, is it between 0 and 15? I think you can do that. If input is greater than 0, greater or equal to 0, and input less than or equal to 15, I don't think we really need to discuss that too much. And then toggle, which we've done. But then all that says is, yeah, basically, is it between those two values? All right. So stage 2, we make a copy. Okay. Now what you'll notice is that we're using the copy. Okay. The copy looks exactly the same as the original. But then the user enters a 6, remembering that our password is, oh, we lost our password. How will we continue? Remembering that our password is 12 and 6 in any order. Okay. So if the user enters a 6, then that bit will be set. Okay. Because it's a 0, as it's a 0, we set it. Okay. If the user enters something incorrect, let me go back. Let me go forward. Let me go back. Forward. Down a bit further. So they entered a 6. So they're so close. If they just enter a 12 now, it'll be unlocked. But they didn't. They entered a 5. Okay. So the user enters a 5. We test it. As it's a 1, we have to reset the whole lock. So we just set lock back to lock copy. Okay. And we get our original lock back. Then the user enters a 6, which sets that bit. And then the user enters a 1, which sets that bit. And because all the bits are 1, the lock is now unlocked. If the user gives up, they can type -1 to exit. Now, how do we do this? Well, that's where the instructions come in. So what you'll notice about this instructions, which is a little bit different. Can I fit everything in? Probably not. But sorry, I'm trying to just get here. No, I'm fighting with the screen with the lab sheet. All right, so the instructions this time are broken up into 2 parts. One is setting the lock password and one is unlocking the lock. And you should treat these as 2 separate problems because they are 2 separate problems. So keep that in mind when you're doing this. Okay. So first thing, meaningful name related to the domain of the problem. I've even put it in red because it's part of the marking guide. The program we're going to create will simulate a digital lock. The steps it follows is as follows. That's not good English, but you can blame me for that. It should just be the steps are as follows. Good one, Matt. Declare a variable of type unsigned short named lock password and initialize to 0b1111. So keep in mind that you have to write the word unsigned. We're doing short. And this part's a little bit tricky because you need to be careful. 0b11111111111111. Okay, so make sure that you've got the right amount of 1s, or else you're going to be chasing the top 1 for a while. Okay, so make sure you do that. Create an input variable to store the user's input of an appropriate type. You can decide on that type. Ask the user to enter the bits to be toggled. Don't accept input yet. Okay. Now this is important because in this task, we actually don't want to ask the user every single step to enter a new bit. And we can look at this on the output example. So it says enter the bits to be toggled, and then we get the first bit, then the second bit, then the third bit, then the fourth bit. What you'll notice is that there's no enter the bit, enter the bit, enter the bit, enter the bit. Like you did in your assignment where you're repeating the prompt, here we're not repeating the prompt. Okay, we're just asking them once, and then we just keep getting values from them. Okay, so this is a little bit different, and that's why it says this: do not accept the input yet. Create a do-while loop that continues whilst input variable. Okay, remember that's your input variable, whatever you called it, is not equal to -1. Okay, you've seen not equal. And in the loop, get the user's input and store it in your input variable. So just a scanf there. And then if the input is between 0 and 15, remembering that our lowest bit is 0, our highest bit here is 15 because we've got a 16-bit variable. Okay, short is 16-bit. We just check that it's valid value that the user's entering. They're not entering something stupid. Always assume that the user's stupid. They'll always try and break whatever you make. And then toggle the bits in the lock variable corresponding to the input value. Okay, so we just use our toggle. So if you don't remember that, we just go back up to the top of the sheet. Now I've included these on the sheet as well, so you can just refer to them. So our toggle is this one here. Now this bit is not going to be a literal like before. It's going to be whatever the user's input is. And the variable is going to be the lock. Okay, so you're going to have something like lock 1 user input. Okay, as simple as that. Now I've lost it somewhere down here. This page got dramatically bigger. Okay, then once they press -1, we make our copy. Okay, create a variable named lock copy as an appropriate type and store the value the lock variable contains in it. So that's literally just going to be unsigned short, lock copy becomes lock. Okay, we're just copying it in there. Print a message to the user that would be suitable at this stage of the program. So at this stage of the program, what are we doing? We're unlocking the lock. Enter the bits to unlock the lock. And that would be a suitable message. Create a do-while loop that continues whilst the input is not equal to -1 and the copy of the lock password variable. So this is the copy version. So I've called that lock copy, is not equal to the unlock condition. Okay, remember we want to continue until all of them are 1. And when they're all 1, the lock clicks open and you can escape. Or you can get access to whatever you want to get access to. Once again, get the user's input. We're not prompting them every time. And then you need to test if the bit corresponding to the input value is equal to 0, not 1. We talked about that by putting the not at the front. And if it's not, meaning if it's 1, we load the lock value into the lock copy variable, resetting the lock and notify it with the message. If it is 0, then we set the bit. Okay, so really you could invert this whole logic if you want and just look for 1s. But it's written like this to try and kind of confuse you intentionally to see if you can work out the logic. Okay, if the copy of the lock variable is equal to blah, 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 print lock unlocked, else fail to unlock. Now this step's important because you could have reached the end, but the reason you reached the end is because the user gave up. They entered -1. So if they enter -1 while trying to unlock, you want to print out fail to unlock. And if it's equal, then the lock is unlocked. All right. All good. Hopefully that was helpful. Hopefully your assignments are excellent. We will start looking at them soon. Let me just have a quick look and make sure no one's accidentally submitted an executable. So With the assignment, triple check that you've got the password and your name, and that what else? Password, name, and that you submitted submitted a C file. Okay. All good. Enjoy the rest of your night. And that's about it. I'll let you say whatever else you want to say. Should find a spot. Ah. Tuesday 19th. Oh, I'm looking at the wrong way. All right. Where's the ending button?